Okay, everyone, good morning. Great to be here in wonderful San Francisco, and wonderful to see many of my old friends and some new people as well. My name is Bruce Momjian. I am one of the Postgres core team members. I was the Bruce that was so humorously mentioned during the keynote. We are here today to talk about Postgres window functions, and the reason I'm starting on time is because this is a very complicated talk. In fact, it is so complicated that I started the talk 6 years ago. When window functions were originally introduced, I was interested in them and started working on a talk, and quickly became very confused about how these things work. I did contribute to improve the documentation for several years regarding window functions, and still was somewhat stymied, got closer, and then was able to re-tackle the problem about 6 months ago, and was able to kind of get the concepts in my head finally, and I'm able to now put it down on slides for you, specifically 80 slides. Yes. So this is actually a 1-hour talk slotched into a 50-minute time slot. There technically is a 10-minute break between now and lunch, and I'm going to take that 10 minutes. I will take a break very briefly if people need to leave at 12:20, but I will be going all the way to 12:30, which is exactly when lunch starts. I do apologize for that. I have had some people, I've given this talk before, and I basically said, tell me what slides to remove to get down to 50 minutes, and they basically said, that is not happening. So that is the card I've been dealt, and we're going to work with those. This presentation, along with many other presentations, is on my website. Unfortunately, it's not going to show right there. Okay, so that URL there at the bottom. This slide presentation is there. A whole bunch of other ones, including a lot of videos of presentations. I don't think I have a video of this one yet, but eventually, obviously, that will happen as well. I do work for Enterprise DB. I've been working for them for 11 years. They do fund a lot of my work in the community. Speaking at conferences, I do about 35 conferences, events a year, and do a lot of work in the community as well. It's been a really fun time, and I go back, as far as Paul, Vixie, and those kind of early years. It is quite interesting to be here today. So what are we going to be talking about today? We're going to be talking about window functions. The reason that this talk became so much of an obsession with me and something that I felt was important to present to you as an audience is that when I originally looked at the window function syntax and started to understand how it worked, I was very confused, and I assume many of you were also confused. In fact, if you start to look around the internet at window functions and examples, what happens is you kind of see an example of a window function in a blog entry. And if you're doing window functions, typically the way you approach it is you find a blog entry that has a window function that kind of does what you need to do. You paste it into your browser, you change the column names, you kind of whack it around a little bit, it gives you the answer you expected, done. All right, and I'm seeing some nods there. That's really not the way I like to do my programming, but I will admit I've done it myself. I had to do a query once that looked at the various versions of Postgres, how many lines of code had been added between each major release, how many months had been changed between each major release, and I did exactly that. I found a window function that kind of did a sort of comparison of rows, and I whacked it around. I'm like, oh, that's the number. Those numbers look good. And I actually put a blog out probably 5 years ago showing that query. You can still on my website. But I really didn't know what was going on. I was really kind of mimicking what that person had done. And the goal of this talk is not to do that, to actually explain what this syntax is and to actually bring you out of this presentation being able to write window functions from scratch, knowing what every keyword means, knowing why you use them, and knowing what they control. There are some impediments to that. The SQL standard documentation is very hard to understand, so I don't recommend you go there. The early Postgres documentation related to this I found to be quite confusing. I have improved it. but also the actual use of the keywords, the way that different options behave in different contexts is also very confusing. We can't change that. That's what the SQL standard defined. So we're basically going to dig in, and we're going to actually understand what these keywords do and why they do them. So by the end, you're going to be in a much better position to use these. Obviously, window function is very powerful, but to me at least also very confusing. And we're going to try and dispel some of that. So let's talk about first introduction to window functions. Window functions are part of a larger suite of features that is offered in Postgres. This is sort of a big kind of bullet list of a lot of the data analytics stuff that we've added in Postgres over the years. And as you can see highlighted in bold there, window functions is one of these. I'd love to talk about all of them today, but heck, it's going to take me an hour just to do window functions. So maybe someday I'll be able to hit them all. This is a definition for window functions. In fact, this is a somewhat improved definition. It's in the Postgres 10 docs, slightly modified from what was in Postgres 9.6, as I remember. And again, you're not going to read this presentation because it's on my website. You're probably going to want to look at it later. You're going to walk out of here and you're not going to use window functions for a month. And then you're going to be like, oh, I need to use one, and you're going to have to go to these slides. So again, there's a lot of detail in these slides that we're not going to be going into. But again, because it's online, you can go back to it. The concept I want you to get out of this slide is basically a window function is kind of like an aggregate in that it allows you to look at other rows that are part of your data set, but it does not aggregate those rows down to a single value. So if you think of the way sum works, it takes a whole bunch of values, it compresses it into a single row. What window functions allow you to do is you could take the sum of your whole data set, but you don't compress down to one row anymore. You still have all the rows there. I know it sounds like, what? But as we get farther, it's going to make sense. So it's basically a calculation across a set of a data set that is somehow related to the current row. And again, the functions will define what that means, but it doesn't compress everything down to a single row. It doesn't cause the rows to be grouped into a single output row like a normal non-window aggregate function would. The rows retain their separate identities. We're going to see that over and over again. It's the concept of using something as powerful in aggregate, but at the same time, each row retains its own identity. And again, there's a whole lot of stuff going on behind the scenes. We're not going to worry about that. Again, this slide is very complicated. The goal here is to make it clear. So what I've done is I've taken some of the SQL queries and I've highlighted the parts in red that you should be looking at. Because as you can imagine, the code becomes very, like, there's just this big query, like, where am I supposed to look? Keep an eye on that red part there. So here's an example of the red part. I'm going to start just kind of setting up a little test environment here. I'm using a select call to a generate series. As you can see, it's counting from 1 to 10. Very easy to understand. And again, the SQL that is part of this presentation is actually at that URL right there. So if you go to my website and you download this presentation, you can actually click on that, and it'll download the SQL file. So anything actually that you see in pink, if you download the PDF from my website, which is online right now, you can walk through it while we're sitting here. You can click on that, and it'll give you the SQL file. The way I wrote this presentation is to write the SQL, then run it through PSQL, and then copy it into the presentation. So everything you're seeing here has literally been run through PSQL, and then you capture the output, and then you paste it, you copy it, you layer it, and you mark it up with red, and boom, you've got 80 slides. Here's the first example of a window function. And again, I'm going to highlight that concept I talked about earlier. What we're doing is we're creating a sum, we're computing a sum, but we are not losing the distinctiveness of the rows in the data set, right? The reason you know this is because this is a window function is because it's got the word over. And over you're going to see, yeah, over and over again. You knew it was coming. You're going to see the word over repeatedly anytime a window function is being implemented or being accessed. And this is probably the simplest one because the parentheses after the over are completely empty. And what that means is that we're using the default values for the window clause. And again, that's a whole snake pit we're going to talk about. But just to give you this example, what this is doing is it's summing the numbers from 1 to 10, okay? But it's also putting that sum on every single row. This is completely useless in most cases, okay? But I'm just giving you the simplest case of a window function. But you can start to see this is not an ordinary sum. An ordinary sum would turn one row. We still have all 10 rows. Good, okay, good. Here's the second one we're going to show you. This is using two window functions. One is count and sum, both of them using over clauses, both of them using empty parentheses to use the default, okay? We're starting very slow. This is going to get very complicated. We're starting slow. Third example, we're now using something called a window clause. This is just a syntax. It allows us to define the window function and give it a label, in this case W, and now I can reference W in my over clause. I don't have to repeat my window definition over and over again. So this is basically a syntax which allows us to sort of define the window specification, and then we actually use that window label in multiple window functions. Okay? As I said, the parentheses define the defaults. I'm actually showing you the default here again in red. And these words are very politically charged. I don't know how to put it. They mean a lot. And they don't always mean what you think they mean, which is another confusing part. So effectively, when you put parenthesis, you are effectively saying range between unbounded preceding and current row. I know that doesn't mean much to everybody. It will by the end of the talk, I guarantee you. Okay, any questions? Okay, great. Let's talk about the window function syntax. You will hate this section, okay, because I am going to show you a whole bunch of syntax that will make no sense to you, and I am very frustrated I have to do this to you, okay? I will tell you that you will come back to these slides in section 2, and you'll look at it again after we're done the talk, and you'll be like, I get that now, okay? I have not figured out how to present the syntax in a way that actually makes sense combined with a whole bunch of queries. So I'm basically going to show you the syntax. I'm going to give you the keywords. I'm going to kind of give you some graphics of how this thing works. And then in section 3 and following, we're going to walk through all the detail. Okay, so don't get upset if it sounds just like completely off the wall, because it effectively is. This is what the syntax looks like, effectively defined by the SQL standard. You have the word window or over, either one, doesn't matter. And then you have a bunch of optional clauses. Partition by, we'll talk about that later. Order by, we'll talk about that later. Then you've got a frame clause, which can have the word range or rows, and then a frame start, and a word between, and then a frame, the word frame start, or between frame start and frame end. Again, this means nothing. You're gonna need this later, okay? There's also the frame itself can be defined as unbounded preceding. That's kind of clear, but I'll show you details of that. With value preceding, current row, following, unbounded following. And again, the syntax is at that URL there. This is the default. Remember when we put the two parentheses, I showed you the default of what that clause looks like. This is it. Word range, the word between, the word unbounded preceding, and the word current row. Those are the three things you have to remember are the defaults for these things. Partition by is not the default. Order by is not the default. Range is the default. Rows is not the default. And again, we'll get into some detail about this. This is a little graphic that shows you kind of what's going on. What I have here on the right, on the left, is a data set from 1 to 5. And in this case, I've got duplicates. So duplicates you're going to hear a lot about. I have 2 1s, I have 2 2s, I have 2 3s, so forth. The first, if I go left to right, the first clause up here at the top is literally the current row. Because remember, we're always talking about the current row, and it's able to compute some number that goes on the current row even though the current row remains distinct. That's the whole concept of window functions. So this is the literally current row, and the way you'd specify that is current row in rows mode is effectively the current row. Okay? And again, this is not going to make a whole lot of sense. I guarantee it will. Second one, that would be a current row in order by mode, where you're using an order by X, and you're effectively using range mode. that is actually a bracket that contains the current row and all the other rows that have matching order by values. Kind of makes sense. I'll show you a lot of examples in a minute. Third one, unbounded preceding to current row. That's the beginning of the data set to the current row. Unbounded preceding to current row in order by mode actually includes the other three that's part of it. The next one, order by X defaults, I'm sorry, the last one is effectively the entire partition. So that would be unbounded preceding to unbounded following. It's the whole range. Giving you a little more specifics here, this is the syntax that would define each of these data sets. So the first one would be rows, current row, and current row. Order by, the second one would be order by X range, current row, and so forth all the way down. Again, terrible that I have to do this, but we're going to come back, and this is going to make a lot of sense to you. Any questions? Okay. Let's actually talk about specific window functions and using generic aggregates, and this will start to actually make some sense. Okay? So here's our data set that we saw a minute ago. Effectively, it's using generate series, numbers 1 to 10, and it's using range mode, and it's saying unbounded preceding to current row, but because there's no order by, you get this 55. And again, I'll show you that in a minute. Look what happens when I switch from range mode, which is our earlier query, okay, to rows mode. Okay, now in range mode, effectively all the rows were considered to be peers of the current row because there's no order by. I haven't defined an equality here. I haven't defined an order. So effectively, it thinks the whole data set is the current row. Or yeah, effectively, that's the way it works. As soon as I go into rows mode, things become different. I now get an accumulated total of this data set. So the 1 is the 1. The 3 is the 2 and the 1. The 6 is the 1, the 2, and the 3. The 10 is the 1, the 2, the 3, and the 4. You see how I'm working all the way down there. Okay? Just by going from range mode to rows mode, now current row actually does mean the current row. It doesn't go all the way to the end. So the reason this is 55 is that in range mode, because we haven't used an order by, it effectively just going to sum the whole thing. It doesn't really, even though I say, here's the thing you got to take. I'm saying current row right here. You see the word current row up there? In window functions, the current row is not always the current row. Now, that is super confusing, but that is the syntax we've gotten from the SQL standard. So when you see the word current row in a query, you cannot always assume that it literally is the current row. And I don't know why they did it this way, but that's what we have. Effectively, we can use some of the defaults. Here's row, unbounded preceding, and current row is the default, so we can get rid of that. I can do this. This actually makes sense. Okay? When I'm in rows mode, if I say current row to current row, it's like, okay, I'm not in range mode, I'm in rows mode, and I want to go from the current row to the current row. That's like my row, right? So there's no calculation going on at all. It's just adding the current row to itself. Completely useless, right? But you can kind of see if I did this in range mode, I wouldn't get this result at all. Okay? And again, I could just use the defaults. I could just say rows current mode because and current row is the default, so I get the same result. Okay? I can do something different. I can say rows between current row and unbounded following. And here, this is kind of interesting. The first row is 1 adding all the way to 10, right? The second row is 2 adding all the way to 10. The third row is 3 adding all the way to 10, and so forth. Okay? So I basically flipped it around by saying current row and unbounded following. I'm now flipping it going the other way. I can use the preceding clause. This is where it starts to get interesting. I'm now saying give me rows between the row before mine and my row. Right? So the 1 is 1 plus a row that doesn't exist, so it's just 1. The second one is actually, in this case, the sum is 1 plus 2, so it's the row before. 5, this 5 right here, I guess I can point at stuff, can't I? Yeah. So this 5 right here is 3 plus 2, right? This 7 is 4 plus 3, and so forth all the way down, okay? Because I'm in rows mode, and I've said one preceding to the current row. Okay, does that make sense? Okay. I can do one following, so I can say now this row here is 3 because it's 1 plus 2, and then 5 is 2 plus 3, and so forth. And when you get down to the bottom, there's no row after it, so it's just the current row. Okay. And this is where you can start to see now, okay, this starts to have some value. I have a lot of examples at the end, but again, it's just kind of get that. I can use other numbers here. I can say 3 preceding in current row. So now I'm accumulating up to 3 rows back. 1 is 1 because there's no rows before it. This one is 2 plus 1, which is 3. This one is 3 plus 2 plus 1. Now when I get to here, this is, let's see, 10, which is 4 plus 3 plus 2 plus 1. But this one only goes back to 3. So 14 is 5, 4, 3, and 2 all added together. Okay? And you kind of roll that forward. Okay. Any questions? Okay. So now we're going to go into, a new area, and that is order by. Okay? So as you know, you can place an order by in your query, in your select query, and order the results. Okay? Interestingly, order by actually can be placed inside of a window function. This is a different use of order by. Remember, order by in a select effectively orders the results. Order by in a window function orders the data set or orders the partition. Okay? And it defines things like peers and what's equal to what and what values are equal to what values. So this is a query where we're basically saying, give me the count and the sum of the numbers from 1 to 10, and I'm going to order by X. Okay? And in this case, it's pretty clear. 1, 2, this is 6 because it's 3 plus 2 plus 1, all the way back. Again, once you add the order by clause, do you remember when I ran this query before, I got 55 the whole way? Do you remember that? It was all 55. Okay? Remember, there's no frame clause here. So it just said 55, but because now I've added an order by, the current row is not the whole set anymore. It actually knows where to stop, and it knows to stop with the current row. In fact, at the bottom it says current row peers are rows with equal values for order by columns, or all partitions if there's no order by. That's why we used to get 55 for this query. Here's a little more interesting. This is the defaults now. Now it starts to make sense. I'm doing order by X. This is a range query, not a row query. But I'm saying unbounded preceding but current row. Because I have an order by in there now, my current row doesn't go to the end of the set anymore. My current row actually goes to the end of my current row. So this is actually changing. Because I've added an order by, all of a sudden the behavior of range changes, the meaning of current row changes. And I'm going to show you a lot of examples of that. Again, you can shorten it up. You could just say, this is another example, range current row to current row, and you can see now because of the order by, each row is itself distinct. Okay? That's just what, and look at the count. The count is actually saying, yes, each row is processing one row. It's only itself. Okay. Any questions before we kind of go into overdrive here? Okay. So now we're going to create a new sample data set. This previous data set had the numbers from 1 to 10, right? All unique. What we're going to do now is we're going to create a data set with duplicates. And this is for illustration purposes. So instead of having 1 to 10, we're going to have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay? Very easy to kind of understand how that works. Okay? So we're going to basically create a table. We're going to dump a bunch of values in there. And again, we're going to work with this data set going forward. Okay? So here's a new query. Again, empty window function. And it's the same thing as the 55 we got before. It's basically adding all rows to all other rows. Okay? Very easy to understand. It's basically just saying sum all the values together. 1, 1, 2, 2, 3, 4, 4, 5, 5, all added together, in fact, is 30. So that we can kind of have expected from what we learned before. Okay. This is interesting. Okay. And it's interesting because now we have duplicates. What you will notice is that the numbers in the groups don't really change. Like the first two rows the first two rows both affect two values. Okay? The second two rows both affect four values, and so forth. Okay? And the totals indeed are grouped together. And the reason for this is because that is literally the syntax that is being used as a default when I type that out. When I type that out, the frame clause is being filled in as a default. And what this is telling me is I want to sum or count from unbounded preceding, which is the beginning of my partition, okay, up to the current row. But as I said before, when you're in range mode, the current row includes any other rows in the set that are equal to your row. Do you remember that from section 2 where I showed you the little brackets that got bigger and smaller? Okay? So what happens in the window function syntax is when you're in range mode and you ask for the current row, it's not just the current row. It's the current row and any other rows that have equal values based on the order by. All right? And I can prove that by changing the word range to rows. So let me back up. This is the query in range mode. And again, range mode is assuming all of my peers that have identical order by values are also part of my current row. As soon as I go into rows mode, you can see that the count is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So it's not including other equal order by values in my set. And you can see that the count, the totals, the sums are changing for every single row. Okay? And that's a great illustration, I think, of the difference between range mode and rows mode. The reason this is confusing is because the existence of order by actually affects how range mode behaves. And it affects what current row means. So there's this cascade of effects. When order by is added, range mode behavior changes, and the meaning of current row changes. And that sort of change of meaning of a term with two indirections is just tremendously complicated. Okay? And this is why I guess it took me 6 years to figure it out. Because it's just this very... When I see the word current row, I just want to say, that's one row, you know, and I'm like, no, it's not the way the system works. I'm not sure I would, you know, be struck with lightning and come up with a better idea, but the use of syntax like current row does make it kind of confusing. Okay. Here's the same thing using defaults. Again, current row, this is range current row to current row. Again, this is all twos. Okay? That's kind of interesting. It's because this really means range current row to current row, and the current row is not just the current row. We're in range mode. We have order by, so it's really the earliest equal value to the last equal value in my order by values set. All right? So this 1, 1, this is a set right here. It thinks that the current row starts here and the current row ends there. It thinks the current row starts here, the current row ends there. Okay? I know this sounds very academic, but once we get into examples, this will start to have some usefulness, which really it doesn't right now. This is kind of a silly example. Okay? If I switch from range mode into rows mode, I get exactly what I'd expect. Okay? First row sees only the first row, second row sees only the second row, third row sees only the third row. Part of the confusion is not only does order by affect what range mode does, which affects what current row means, but the default for, if you don't specify it, the default is range mode, which is the confusing one, right? If they defaulted to rows mode, I kind of get it. Like, you know, okay, if I want an order by, then I go into range mode, and then something funny happens, right? But the default is range mode, so therefore, if you don't specify anything, you just get the whole data set. It's a very weird syntax. And that's why when, and I'll talk about this later, but when I start to recommend people writing window functions, I'm going to recommend that you fully spell out exactly what you're doing. The idea that, I don't have to type that extra text, like, don't go there. Because this stuff is confusing enough without trying to throw a default in there. And I would almost say that maybe the use of defaults was a huge mistake. That maybe we should have required we can't change that because the SQL standard has defined it, but don't short circuit yourself in trying to use defaults in a lot of cases, because it's not there, so you don't see it, so you don't remember what the crazy defaults are, and then you're going to, and the killer is you'll get fine results for a while, and then when you have some duplicates in there, then you'll start to get weird results, right? That's not a good thing. All right. Any questions? Okay. So let's introduce another new clause called Partition By. And again, I started with the original syntax. I added order by. Now I'm adding partition by. Okay. And what partition by allows you to do is to break up the query, break up the data set into partitions. So instead of having unbounded preceding go all the way to the beginning of the data set, unbounded preceding is going to go all the way just to the beginning of the partition. So now you have two concepts. You have the order by concept, and then on top of that, you got the partition concept, which allows you to sort of break the data set up into groups. And I'll show you some examples, specific examples later on of when you might want to do that. Okay. Now, by adding partition by X, it effectively behaves as though it's a range query, because now instead of having equal peers, instead of having an order by X where, current row 1 is the same as current row 2, now I've created a partition. Now the first 2 rows are all partition. And the second 2 rows are all partition. And the third 2 rows are partition. So there is some overlap in how this behaves. Okay? I'm not going to deny that. What I'm going to do to illustrate is I'm going to create 2 partitions, which I think will be kind of clear. Okay? We have the first partition, which is all the values less than 2. Less than or equal to 2, I'm sorry. And we have a second partition, all the values greater than 2. Okay? And I've colored them up, so it should be pretty easy to see. And effectively, I've used the defaults. I've done what I told you not to do, right? And the whole default here is range by unbounded preceding to current row. So effectively, all of the red rows are considered to be in a single partition, and when I go to do a sum, it just sums all the numbers together. So 1, 1, 2, 2 is summed together. Okay? The second group in blue, again, unbounded preceding to current row in range mode. It's that row, number 3, all the way to the bottom. That's my entire set. Okay? So we shouldn't be surprised we're getting this. If I throw an order by on top of it, now I'm taking 2 concepts, I'm merging them together, okay? And you get a little different result. Now, because of the order by, effectively range unbounded preceding to current row gives me the first 2 rows are considered to be a peer group, so I get 2. The second one, again, are peer groups. So I've now got 2 partitions, and then within those partitions, I've got peer groups based on the order by, based on what values are equal. And because we're in range mode, the behavior and the meaning of current row is changing. I mean, if I had to write down what I'm actually saying, and just look at it flat without the context, it would make no sense at all. I sound to what I'm saying, I'm like, that makes no sense. But when you actually are looking at the query and I say, well, it actually makes sense. I know this. This is why it took 6 years for me. Okay. I will also say I did not find a whole lot of documentation on exactly on this level of detail. I saw a lot of examples of people using it. I saw the SQL spec, but there's not a whole lot of people talking about window functions on any database at this sort of level of detail, kind of breaking down each keyword and explaining what it means. Okay? They sort of assume you know, or you've played around with it enough, or you've copied somebody else and you're happy. Again, this query effectively has all these defaults, and this is why you're getting this, because it's partition by, it's order by, and then there's all this range between unbounded preceding and current row. That's why you're getting these results. So we're layering all the things we've learned in the past 35 minutes kind of on top of each other to get to a result that has something that actually makes sense, even though it's layering 3 or 4 or 5 concepts on top of each other. Okay? As soon as I switch from range mode into rows mode, I get a different result, because my current row means literally my current row now, and effectively I'm not getting 2, 2, and 6, 6. I'm getting 1, 2, and 4, and 6, because that's the way they're being aggregated. Okay. Any questions? Yes, sir. So the question is, are there no peer groups in rows mode? That is absolutely correct. When you are in rows mode, current row always means current row. In range mode, which is the default, I will unfortunately say, current row means either the entire partition, or if there's an order by in range mode, current row means my row and all rows that have identical order by values. I know, if I had to write it down, it would make no sense, but it actually, I can get it in my head. And I'll remind people that all these slides are online, so you probably are going to need to look at them when you finally get to your first query to like do this, because there's some stuff at the end that has slides, and you almost have to digest it for a while to kind of get it into your head. Yes, sir? Yeah, yeah, I think I'm more worried about so the point was we should have just called it current value. For range mode, yeah. I don't know if I should blame that or the defaults. I'm not sure where I want to go. Or the fact that there are any defaults maybe is my problem. I don't know. But I do know that there's a lot of people who do use this, but they're very specialized. So there are people who are using this every day as data scientists, and they get it. But there's not a whole lot of material for people who are coming in to kind of get it without sort of a lot of sweat and tears. Yes, sir?
So partition by is the default, I think, makes sense.
Yeah, partition by is very clear, yeah.
Yeah, because then you're always copying the whole partition. Order by is
Right, so he's saying partition by is very easy to understand. Order by is a little trickier, and its behavior on range mode and current row is where it starts to get tricky, is the cascading effect of that, yeah. As soon as an order by shows up, if you're in range mode, current row is now different, and that's 2 levels of indirection. It's kind of hard to catch it, and the documentation is just not, I've never seen it clearly stated that way, but effectively that's what's going on. Yes, sir? So the question is, are there clear documentation on what the defaults are? In fact, there's very clear documentation on what the defaults are. And also, you will find, this is a concept we're going to talk about later, but there are some window functions that behave on frames, and there's some window functions that behave on partitions. And when you read the documentation, you think of partition and frame, oh, it's kind of the same thing, isn't it? Like, and this is what actually caught me up, that the Postgres docs, and certainly the SQL standard specifically, has specific meaning for what a partition is versus specific meaning for what a frame is. And for each function that you're using, you need to look up the documentation to see, is that behaving on a partition or frame? So my point is, we haven't talked about it yet, my point is that the documentation is very clear. You just need to be aware of the terms that are used and make sure you understand their meaning when you're reading it. Because a lot of times when I'm reading definition for a function, I'm looking for what it does. I'm not necessarily looking for the particular term that they use to describe what it's operating on. And that's what often catches people, I think. Yeah. Other questions? Yes, sir. So can partition by use multiple expressions? Yeah. Yeah, it can be a bunch of stuff. Well, actually, in this case, I used partition by, I used an expression. So I used x greater than 2 as my partition by. So you can put anything in there. Yep. Other questions? Okay. So let's launch into the brave new world. This is where we kind of get off the runway. Okay. I know. Yeah. We're 43 slides in. We're just getting off the runway. What I'm going to talk about here are specific window functions. Up until this point, I've used count and I've used sum. Very simple. I've used what we call generic aggregates. And I've used those generic aggregates in window functions. Now I'm going to show you window-specific functions. Right? I haven't introduced any new functions yet, but now I am. First one, row number. It's really easy. It just numbers the rows. Okay? It's just, and again, it's going to just give me the number. Okay? Notice the text at the bottom. This is exactly what I just talked about to the gentleman. Row number takes no arguments and operates on partitions, not window frames. What that means is that it doesn't matter whether you're in range mode or rows mode. It doesn't matter what frame clause you use. This is going to number the rows in your partition. Okay? It's not going to, it doesn't care about the frame at all. This is the point. When you look up the docs, it'll say, numbers the rows in the partition. And you'll be like, okay. And then you'll see another function will say, operates on frames. And you're like, okay, isn't that the same? No, it's not the same. It's actually different. Some window functions are affected by frame clauses, and some window functions are not affected by frame clauses. And that's kind of one of the takeaways we have to get here when we start. That's why it's so multifaceted. But that's a very simple function. And a window function we haven't seen before only operates on windows. You can't just call it yourself. It doesn't make any sense to call it yourself, right? It's not a generic aggregate, as we call it. But it does operate on partitions. Okay, very easy to understand. I think it just numbers the rows. Lag, this is a new one, another new one. Instead of saying preceding to current row, right, this actually just looks backward and pulls the value from how many rows behind you in the partition. Okay, so here I'm saying give me the current row, remember 1 to 5 duplicates, and then give me, for the second column, give me the value that's in the row before mine. Okay, and you can see the first one is null because there is no row before it, and all the other ones just shifts it down. Okay, pretty easy to understand. Same thing, I can do lag 2. I can say give me 2 rows before it. First 2 rows don't have any 2 rows before it. Third row does. Okay, I've shifted everything down 2 in this case. Pretty easy to get. I can do lead. Lead says go forward instead of backward. Okay. This one is lagging 2. The second column is lagging 2. The third column is leading 2. All right. Take a look at the bottom. These operate on partitions. Doesn't matter what your frame clause is. Doesn't matter whether you're in rows mode or range mode. It's going to go back 2 rows in your partition, but it's not going to go across your partition. It's not going to go outside your partition. Okay. And you can also specify defaults for non-existent rows so they don't come out as null if that's important to you. Here's another one. 2 new functions, first value and last value. Okay. This is going back in your frame. See the word frame at the bottom. Okay, now it matters what my frame is. It didn't for the previous ones. It goes back in my frame and it says give me the first value in my frame, and this third column says give me the last value in my frame. Okay, pretty easy to understand. Effectively, first value in the frame. Oops, sorry. Is always 1 because it goes at the beginning of the thing. The last value in the frame is always, well, we have an order by x, so it's technically the last peer matching value of the order by. Remember, now we're layering all this stuff back over top of each other. Okay? But that's what first value, last value does. It gives me the first value or the last value within my frame. This is like, whoa, what happened, right? I just threw this out here as a craziness, just to illustrate craziness, okay? I don't expect you to write any of these functions, but for illustration, it's very clear. What I'm saying here is I've already told you the first value and last value operate on frames, and now I'm defining the frame, as being unbounded preceding to unbounded following. It doesn't matter whether I'm in range mode or rows mode or not. I don't know. It doesn't matter whether I'm range mode or rows mode or not. Probably the order by doesn't even matter. Okay? I'm basically saying give me the last value in my frame. Or in my frame, I define my frame as being the entire data set, the entire partition, effectively. Okay? And that's how I got the 5. Nth value, this gets a little more tricky. Give me the third value or the 7th value within my what? Frame. Thank you. Within my frame. Give me the 7th value within my frame. So the frame clause is effective here. Okay? And again, it's going to give you nulls for values that don't exist, and it's going to give you the value if it has it. Again, this is because these are working on frames. This is default because I didn't specify the frame. It is using this default frame clause, which explains why we're getting the values we're getting. Okay. Here's another one where I'm now saying. Now remember, this one is this is kind of crazy. This is unbounded proceeding to current row in range mode, right? We get that. We understand what that means. When we switch to rows mode and we do unbounded preceding, unbounded following, somehow it knows all the rows are there. Like, how did that happen? Okay? It's because we've defined the frame as being the entire data set now. So it has no trouble figuring out what the third value is and the 7th value is because every row can now see every other row. I know it's kind of weird, but that's what it is. Okay? The reason these nulls are here is because the third column can't see the third row because we've cut it off at current row. The reason the third column doesn't have a 4 until almost the end is because it isn't able to go forward because our default frame clause is saying current row. As soon as we open it up, it's like, I can find the third row. I can see the whole frame now. Even from the first row, I can see the whole frame. All right? New function. This is, we're getting really, getting interesting now. There is a rank function and there's a dense rank function. And what these are attempting to do is to rank my values based on some ordering, okay, in the partition. We're back to a function that doesn't work on frames, that works on partitions. Okay? So I basically use dense rank. If I specify no frame clause at all, I've got completely nothing, completely useless data because I haven't told it how to order the result. You can't order the result. You can't give me a rank without telling me how to rank them, how to order them. I need ordering to get rank. So as soon, and again, with these defaults, I still have no rank. If I go to rows mode, I still have no rank. But if I had an order by, then I get rank. Okay? I don't even know why it lets you call these functions with weird defaults, but it does, right? So here's an example, and these two columns are pretty illustrative. What the second column is telling me, it's ranking them based on the order by, but it's using rank, which means if there are two first place finishers, the next person across the line is third, right? Think of a race. If two people cross the finish line at the same time, the next person who crosses is, I don't know, right? They could be third, or we could use dense rank, which is what the third column does, and it assumes that person is second. I don't know why it's specified that way, but that's okay. Okay. So effectively, what happens in this example on column 2 is you have two first place finishers because they are peers. Okay. And then, and then right here, and then this person is third because there are two first places. Okay. And then there's 2/3, so the next one is 5th. And there's 2/5, so the next person is 7th. Okay? If we do use dense rank, which means don't gap it, just because 2 people finished first doesn't mean we can't have a second, okay? Then we have 2 people who are first, and then this person is second, and there's 2 seconds, and then third, and there's 2/3, and so forth all the way down. Okay, nothing wrong with that. It's just a question of how you want to interpret it. Okay. Another function, percentile rank, cumulative distribution, and entile, is trying to break up the data set into pieces so that you have effectively what percentage, percentile rank is saying what percentage is less than my peer group. So that's 0, okay? At this set, 22% or less, 44% or less, 67% or less, 89% or less. That's because we have peer groups up here. Over here, it's saying what percent are equal or greater, equal or less. So we're assuming my peer group and less. What percentage equal or less? And that's easy to understand, 20, 40, 60, 80, and 1. Okay. Over here in entile, this makes sense. This is all of the first, third, second, third, and third. So it's trying to break it up into chunks. Okay. Throw a partition by in here. Now we're back to this partition that we saw before, but now we're running ranks. Notice the first partition gets ranks, 1 and 3, 1 and 2. Second partition, completely independent ranks. Okay, it's like a brand new data set to the partition function, to the ranking function. Okay, so these rows are first in this partition, these rows are first in this partition. Very easy to understand. Okay. Again, as I said, I am going over time. I will take a 10-second break. If anyone wants to hop out, I don't want you to feel embarrassed. So I'm just going to hold it here. I'll give you 15 seconds. If you want to you run quickly. Yeah, let me take a question. Yes, sir. So in all the examples, the rows are partitioned by x greater than 2. It could be anything. I just threw that in there. Yeah, it could be ordered by anything. Yeah, I don't have to make it ordered by x. I could be ordered by anything. And I have some examples later that actually change that. You'll see later on. Okay. So I think we got people who want to rush to lunch. Now we're going to finish till 12:30. Window function example. So we're going to take all the things we've learned, and we're actually going to show real-world queries that use the information we've learned to actually produce useful results, because that's what it's all about. I've given you some crazy queries up to this point. Now I'm going to give you realistic queries. Okay, great. Okay, first let's create a temp table. Emp table, we're going to throw a bunch of employees in here, different salaries, different departments, different names. Again, we have a tutorial down there. Okay, this is what the data set looks like. We have 7 employees. They're in different departments. They have different salaries. Okay, but this is going to be very, very illustrative of window functions. So first, let's run a generic aggregate. This isn't using window functions at all. It just says how many employees do I have? What's the total salary and what's the average salary? Very straightforward. No window functions, nothing. Okay. Let's do a group by. Again, no window functions yet. We basically have give me by department how many people in each department. What's the sum of that department and what's the average of that department? Okay. I can use Rollup. Rollup I added a couple years ago in Postgres. It allows me to get totals by department, plus it allows me to print a final total of the entire data set. Very good use of Rollup. Okay, if you've ever seen Rollup before, that's what it does. So let's go back to our data set. 7 people, ordered by salary descending. Pretty easy to understand, right? 7 people, pay different salaries. Let's use a window function. This is exactly the same window function. It was the first window function I showed you 54 minutes ago. Okay? Remember we had all those 55s down the beginning? We're like, wow, that's kind of weird, right? What we're doing is we're saying for each row, leave those rows distinct and give me the sum of that, of the data set. It's exactly what we had way back in the beginning. It looks completely useless. Now for each person, I can see exactly what they are. okay? I can now order them by salary. So this is actually cumulative from the least salaried person, okay? I'm sorry, cumulative from the highest salary all the way down, and it's adding up the salaries as I go. This is very useful for time series data. So for example, how much rain have I gotten this month? And you can actually have it from the beginning of the month. You can have per day, and then you can have a cumulative rain from the beginning of the month, beginning of the year, whatever, beginning of the day, whatever you want. Okay. Here is a window average. This is kind of cool. Now I've got this person, the salary, and now I've got the average of the salary for all the employees, but I've retained the distinctiveness of the rows. That's what, I think, slide number 2, we talked about that. The concept that aggregates allow us to compute something but maintain the distinctiveness. And it didn't sound very useful, but now it looks kind of useful. Because I still see my 7 employees, but I have a new column which is looking across the entire data set, which is giving me an average for the whole company. And I can do something like this. I can say, for each employee, show me their salary, show me the average of the entire company, and then give me the difference between that person's salary and the average salary for the company. You can see how this is starting to get actual meaning to it. And I've colored it, so I've made all the red people are over average and all the blue people are under average. Okay? We can do more. I can say, take my employees, order them by salary descending, and then tell me how much more that person is making than the next salaried employee. So I'm now saying for every employee, give me the most compensated first to the least, and then show me the difference between that employee and the next one. And you can see exactly what we'd expect. The last value is null because there is no value after it. Okay? And you can see the 0 there right here. That's because these two people make the same salary. Right? So there's no difference between the two of them. Makes sense. Okay? A little more interesting. Compare the lowest paid employee to the other employees as a percentage. All right? So what I've done, and this is kind of cool, I computed last value. Remember last value says give me the last value in my partition? So give me the last value ordered by salary descending. Okay? Because remember, I've defined my window function. Here I've used W as ordered by salary descending between unbounded preceding, unbounded following. So I can see I have my whole data set. I'm ordered by salary descending. I'm saying take the current salary and subtract it from the last salary and divide it. I'm sorry, that's what this column does. This is telling me how much more are they making than the least compensated employee. And this is giving me the percentage they're making of the least salaried employee. Okay? I can rank my employees from salary-wise. Okay? So this is kind of similar to order by, and also I can use dense rank. If I have 2 employees with the same salary, do I want the next one to be 6 or 5? Right? Makes sense. Actually, it seems like a reasonable idea, right? And good use of dense rank, I think. Okay? You decide how you want to handle duplicates like that. The wheels start to come off here when I decide that I actually want to compute my averages and my differences by department. This is because a lot of times you get into a case where you want to look at department changes and you don't want to compare somebody in marketing with somebody in sales because they're just different purposes to the company, let's say. Okay? So now I'm looking at marketing compared to the other person in marketing, and I have a difference to the average. I look at sales, their difference from the average, and then I can look here. These are my salary differences for my shipping people compared to the average, not of the company, but the average of the salary in the shipping department. notice how I specified partition by twice here? I can use a window clause, right? And now I don't have to do that anymore. I can tighten it up a little bit. Same results, okay? I can even compare me to the next, compare my current salary to the next salary in the department, but not some other department. So here I'm $800 more than the next person in the department. That person, there's no other person in that department, so it's null. Okay? Here again, same type of computation, but now I'm looking at it not within the whole company, I'm looking at it only within departments. Okay? I can even get crazier. I can get in column 4 the rank of these people within the department, and in the last column I get the rank within the entire company. So column 4 is using a partition that column 5 is not using. Right? Here, 1, 2, 1, 2, 1, 2, 3, within their departments, this is their rank within the whole company. See, it's really powerful. Once you get it, like it actually has a lot of use to it. Any questions? Yes, sir.
Can you speak into performance of window functions as opposed to other ways of
So the question is, can I speak into the performance of window functions compared to others? Window functions require you effectively to generate the entire data set before you're able to actually compute these values. But the actual computation is not significant burden. So the only problem with window functions is that you have to compute the entire data set and then go through a second phase which just computes these additional values. But I've never heard of anyone complaining about performance of window functions themselves. Yes?
I'm ready to complain, actually. I am going to complain about performance of window functions.
Okay, I will talk to you after. Thank you. Other questions? Yes, sir.
I'm not sure about the Postgres, but generally things like cumulative, aggregates are just orders of magnitude faster with window functions than if you would try to do it with correlated software.
Right, so that's a good point. The gentleman was saying using window functions is certainly faster than trying to do this yourself, trying to do it in a server-side language, trying to do it on the client. If you can do it with this syntax, it's almost always going to be faster than any other option you have. Yeah, great point. Thank you. Other questions? Okay. So let's just summarize what we learned. Yes, sir. I'm sorry.
the order by in the window clause is completely independent of the order by in the
Great question. So he's asking, is the order by in the window clause completely independent of the order by in the outer query? And the answer is yes. Usually, if you use the same order by in all of your window functions, the result ends up being ordered by what you did, but it doesn't technically have to be. So I always tell people, still use an order by clause at the end. Yeah.
Can you do a different order by?
Can you do it? Absolutely. You do not. You can use completely different. In fact, in this example, I've used, I guess I don't have example, but you can use different order bys in different window functions, and you can use a different order by as a result. Yeah. So walking through exactly how you need to look at window functions. First, this is sort of for me, the sort of recipe. Do you need to split the set, or are you just going to operate the whole set? Use partition by if you have to. Do you want an ordering in the partition? Again, use order by if you have to. How do you want to handle rows with the same order by value? If you've used order by, how do you want to handle duplicates? Do you want range mode or do you want rows mode? We talked about that in very great detail. Do you want rank or dense rank? Also related to order by duplicates. Okay. Do you need to define a window frame? Are there any of your functions work with frames? Do you want to use the defaults? Do you want to specify it out? That's your decision. Window functions, as I really relate to the gentleman who was asking the question, window functions can define their own partitions, their own ordering, and their own window frames. You can have 20 different window frames and 20 different functions in the same query and have a separate order by at the end. Works fine. Okay? Multiple window names can be defined. I've only used a single window name here, but you can define multiple of those. Pay attention to whether the functions operate on frames or partitions. Specifically this slide you will want to probably look at later. Okay? What does it do? It categorizes the two types of functions as either operating on frames or operating on partitions. Okay? And within those sections, we have computational window functions, which are effectively generic aggregates like these, okay? We have frame functions, which operate on first value, last value, nth value. Again, use the frame word here. And then we have a whole bunch of functions that operate on partitions, have nothing to do with frames at all. We don't care whether you define the frame or not. Okay? And this is probably why they don't require you to specify frames, because a lot of functions don't even need frames. Okay, so they have to have some default, I guess. So they're row access functions, which again work on within the partition, and then there are ranking functions, which again work on partitions. And again, a window function never goes outside its partition. Okay. And that is it. Yay. I appreciate you. Thank you.